Okay, so welcome back once again, guys. Now, in this lecture, I'll be talking about finding out a skewness into a data with the help of mean, median, and mode. So last time we have used a skewness formula, but yeah, so this time let's try to talk about a mean, median, mode, and then try to understand that what is the skewness into a data set. Again, so skewness we are trying to find out to understand nature of the data, that whether my data set is having some sort of outliers or it is not having some sort of outliers. So let me share my screen and it's visible to all of us now. So I'm going to take an example of the data. So skewness with mean, median and mode. Yeah, so mean, median and mode. So here I'm going to consider a data. So let's suppose I have a data D1 and value is, again, I'm considering the previous data set itself because with that I have done the calculation. So 11, 10, 11, 12, 13 and then 14 and then 18 and then 30. So this is my data number 1. My data number 2 is basically 2 and then 10 and then 11 and then 12 and 13 and 14 and 15. Okay. And I have data number 3 and basically value wise 10, 11, 12, 13, 14, 15 and 16. Yeah, so we have basically these three data set and we have to find out with the help of this mean, median and mode comparison that which data set is technically skewed and which data set is technically not skewed. If my data set is not skewed, in that case it is supposed to form a normal distribution curve. So where we have a mean over here, and again, so at the same place I will be having a median and at the same place I will be having a mode. So means if data set is not skewed or if data set is 0 skewed, so in that case, so if data set is 0 skewed, so in that case mean is equals to median is equals to mode, or you can say approximately equal to, yeah, not exactly but maybe approximately equal to mean is equal to median is equals to mode. And I believe we all understands how to find out a mean, median and mode. If my data set is positively skewed, so in that case our mean will be greater then median will be greater than mode. Yeah, and if data set is negatively skewed, so in that case my mean will be lesser than my median is lesser than my mode. Yeah, so this is something that you will be able to identify. Fine. So here we can try to find out a mean, median and a mode, and with the help of mean, median and mode I can try to say, or I can try to identify that whether my data set is skewed or not. Okay, so that's cool. Let's try to find out mean, median and mode for my data number 1 and then my data number 2 and then my data number 3, and with the help of that let's try to understand it, that whether my data set is positively skewed or my data set is negatively skewed. So here I'm going to consider my data number 1, let's suppose, and which was having a value, so 10, 11 and then 12 and then 13 and then 14 and 18 and 30. So just by looking into a data we can understand that we have a very high value, so which is not falling under the other distribution. So obviously this data set is having a positive skewness, but we have to prove it with the help of mean, median and mode. So if I'm going to find out a mean of this data, so summation of this whole data divided by total number of the data. So total number of data is equal to like 1, 2, 3, 4, 5, 6, 7. So just add it and then divide it by 7. So this is going to give you 15.43, right? And then median, right? So median, so what is a median of the data? So obviously this 13 after sorting this data into ascending order. So let's suppose like we have 13 over here, right? We have a mid value is equal to 13. And what is a mode? So node data is frequently repeating itself. So mode in that case, I can say 10, the lowest one. Yeah. So this is the observation that we have. So here we are able to find out that my mean is greater than my median over here is greater than my mode. So this clearly falls under this one, right? This clearly falls under this one. So I can say that my data set is positively skewed over here. And again, just by looking into our data, I can say the same thing, right? 30 is on a higher side. So obviously, if like I'm going to like plot this curve, so this will look like this one. So on a positive side, we have some value, we have some x value, and because of that, right? Because of that, it is trying to form a right tail, right? Right tail it is trying to form. Same thing we have observed with the help of even skewness formula. Now, same calculation I can try to do for my data set number 2, where I have 2 and then 10 and then 11 and then 12 and 13 and 14 and a 15 over here, right? So what is my mean, by the way? 11.0. What is my median? So I think we all know what is like how we can do the math. So median is the mid value. So basically it's a 12.0, and then my mode. So it's going to be 2 for me. So here I can clearly observe, right? Here I can try to like observe very clearly that my data set is negatively skewed. Okay, so now here you can ask me one question that I have mentioned mode is equals to 10 and I have mentioned mode is equals to 2, right? But what is the meaning of a mode? A mode is nothing but most frequently occurring data. Now, so if you are going to count the frequency of any of this data, frequency is equals to 1. And even with respect to the previous data, my frequency was equals to 1, right? So if you are going to use a stats library, so maybe SciPy library, if you are going to use, it is going to return always the first value by default, yeah. But statistically speaking, there is no true mode that we have inside a data. That's a reality. So it's basically inconclusive. I can't do the comparison. So even in the last part, so I was supposed to remove this one. But yeah, as it was like a supporting my theory, so I have taken that. But here, obviously, it is not going to support my theory. So where mode is greater than median is greater than mean. And again, so this is inconclusive. As we have a frequency is equals to 1. So there is no clear mode, by the way, in like a data set, as simple as that. So, but yeah, like I said, so if you're going to use a library, you can test it, by the way. So if you're going to use a library, although there is no mode, but it is going to give you the very first value. Yes, so you can test it out and then let me know in a comment what you are able to find out. But yeah, so here, if there is no conclusive mode, what I will do, so I'll try to technically do the comparison between only median and mean, by the way. So here my median clearly is stating that it's greater than mean, and somewhere, right, somewhere it is falling in this particular assumptions that we, or like this particular theory that we are talking about, right? As mode is inconclusive, mode was even inconclusive in the previous one. So here I can just do the comparison between mean and median, and my median is bigger as compared to mean. It falls under a negative skewness. So I can say that okay, my data set is falling under a negative skewness. But again, I'm repeating myself, mode is inconclusive over here. If you are going to use a library, it is going to give you the very first value after sorting the data, but it is inconclusive, as simple as that. So here, when my mode is inconclusive, in that case, I can do a comparison between median and mean only. Yeah, so I can try to leave the mode part. So this is about a story about a data number 2, and if I have to talk about the story of a data number 3, so data number 3, so where we had 10 and then we had 11 and then we had 12, then we had 13 and then we had 14 and then we had 15 and then we had 16, right? So even in this data, so it was clearly like visible that there is a value on a left hand side. So it is going to form a left tail, or data set is negatively skewed. You can even try to calculate the skewed, which we have done in my previous lecture, right, with respect to the same data. So here, if I'll talk about a data number 3, so my mean is 13.0. My median is 13.0. My mode programmatically is going to be 10, but statistically it's inconclusive. Yeah, statistically it's inconclusive, but yeah, programmatic way, so you will be able to find out. So here I can say that mean is approximately equal to a median and approximately equal to mode, right? Approximately equal to mode. Again, like I said, so programmatically it will give you this 10, but statistically it's inconclusive because frequency of all the data set is equals to 1. So I can't conclude it that this is the true mode for me. But yeah, in terms of programming, I can do that. So I can just take this two comparison, mean and median, and based on that, I can simply say that okay, so my mean is equals to median, and which falls under this zero skewness criteria. Mean is equals to median. So this data set is not at all skewed, and this data set is symmetrically distributed across a plane. As simple as that. So hope with the help of this mean, median and mode comparison, so we are able to understand a lot. So with that, thank you so much everyone. Take care and see you again.